let's talk about multi-zone. What is some of the hardware, and then everyone's favorite thing of RF over fiber. So let's start with some basic ideas, and a lot of this is Wizy equipment centric. The receivers for all this you can interchange for the most part. We get into some things digital we'll talk about later, but this is going to be a little bit more Wizy centric just because of some of the hardware is very Wisycom specific. So let's talk about some basic examples of, this is probably a situation some of you have been where you have a cart and you have your pair of antennas. We've graduated from, we have the whips on our receivers to now we've got a, rack receiver and we've run a pair of antennas out. But now production says to you, well, cool, I want to have a zone down the street because I want to do a walk and talk from, let's say, up here down the street to Pig Beach. And you say, that's super cool. I'd love that idea. This is going to be super easy for me because I love RF. So that's kind of the question we sit in is how do we manage that? So the basic idea, and we'll dive into a lot of how this matters in a moment, but you take something like our MRK16 and we've got this fiber card in the back, and now when production says, I want a second zone, you say, that's easy. I'm going to run my fiber strand out. I'm going to put a pair of BFLTs on the far side, and I'm going to put a pair of antennas out there, and I'm going to sit comfortably at my cart, and I'm going to sip my coffee, or depending on how the day goes, maybe it's a whiskey. I don't know. You live your life. Easy, right? It's easy. Class over. I'm kidding. So, but, what about when production gets a little more complex? That they say, okay, well, we're going to do, let's call it a police show, and there's a police chase that starts here, it goes downstairs, and we're going down the block, and then we're going to go down into the subway. You're going to say, dude, that's super fun. I love that. We can do this. So we'll say, I'm going to run multi-zone. Or for more of a reality example, my wife has been watching Love is Blind, which I don't know if you all or your significant others make you watch that as well. I just hear it in my house. So she asks me, well, how do you do that? How did they make that happen? So let's take a probably more common example to some of you is, let's say we're doing a reality show and I need to have coverage in, for if you haven't watched Love is Blind. There's the boys' room, the girls' room, the pods, and then what I'm suspecting is a different area, the meeting area, right? So let's call it 4 zones. I would say, well, let's put a pair of antennas in the boys' zone, and then a pair in the girls' room, a pair for the pods, and then because the other room is far, it's fiber. If Tom were here, the question he'd be asking, because I was supposed to give him question cards that he was supposed to ask me, that's my fault, I didn't for this one, is how can I have multi-zone? Great question, Tom, thank you. He's on the phone. So how can I have multi-zone? So a lot of this is based out of just some hardware. So we make a couple of boxes for this. One is called the MAT288, and this is a diversity matrix antenna combiner. On the table here we have the 244, which is the slightly smaller version that does 4 zones. So you get the option to do up to 4 zones or up to 8 zones. Any questions on anything so far? Is this kind of tracking? So we take this MAT. When we have a situation where we need to start expanding, all we have to do to add another zone is an antenna in the A, antenna in the B. So we were discussing in the break here, well, what about a situation where I want to have antennas that are directional and antennas that are omni? I generally, the rule of thumb is your antenna should match. If one's a directional, they should both be directional. So I might say then, well, it's a large space, let's put a pair of directionals, add a second zone, that becomes our omnis. So one of the cool tools on here that I think is up here still is the RF bars. So we have these RF bars here, and this is showing your real-time RF level. So right now I've got antennas plugged in. There's an omni on 3 on the B side, and then this directional antenna on the A side. What this gives you the ability to do is be mindful of how much total RF level is coming in. Because while the entire game we're playing is the same thing as before, is signal to noise, we also want to be mindful that as you add zones, you're increasing the cumulative level of RF energy coming in. So that's where we start getting into attenuating, because when you don't attenuate, I have more radios now. Cool. I don't know which one of these is on. You start adding more things, then you get a two-way radio that comes in, and now we've oversaturated. Even if we're further away, we start oversaturating our receivers, which, depending on the receiver, will cause your audio to drop, cause lots of problems. If there's not a mic on it, will cause it to break, squelch, huge amounts of noise coming through. Oversaturation is a bad situation. So will any antenna work? As you can see, even just sitting here, we've got a passive antenna, we've got an active filtered antenna. Wisycom makes a couple of antennas that are very, very nice. On the passive side, we make what we call the LBN2, which is effectively the same shape except minus the electronics, just a BNC or N connector. As well as on the passive side, we make the ADB, just a BNC connector or with an N type. And you might be asking, your next question is, well, should I be using BNC or N type? And the answer really ends up being like, what is it you're doing? There are a few companies even in the US that will exclusively use N type because they like the durability of it, especially on long cables. When we start getting into and I'm sure, I don't know if you all have one here, Nate, somewhere like LMR 400 or like a 9913. If they have like a spool here, I'll show you. If you haven't seen like a 100-foot spool of cable, it is massively heavy. And, when you get to like 200-foot runs, you're hesitant to put a 200-foot run on the little BNC connector. The other side of it being for water resistance. The antennas themselves are water resistant. It's the connectors, your point. Because even without that, you get any level of voltage and water and it starts going badly. All of these, for the passive ones, they do a bit more, but the range that matters to us in the US is 470 to 960. And they'll all do that. The passive antennas are transmit or receive. And this is massively important because in a moment, we'll get into the active antennas, which are receive only. The rule of thumb for Wisycom is anything with a display is a receive only. And the reason being, we were talking about this on the live video earlier, is it's got to do with the total amount of power. Mic receive is very, very, very low power generally. Transmit ends up being very, very high power. So in the same thing we were talking about earlier, you get the selectable filters of low pass, high pass, a 40 meg filter, or a country specific SAW filter. So for the US, it's a 940 to 960 meg SAW filter. So any questions on any of those things?
How does it work with like transmitting or receiving, or it does both at the same time?
It does one at a time, but you can use in either application. So this could be a receive antenna or separately a transmit. And a lot of the application we'll get into for the next little bit is all on the side of receive. Transmit is a smidgen of a more complex topic, and it gets more depending on how many channels and where you want to put it. And it's something I can happily go into, but I've found the amount of people who are interested in talking about multi-zone transmit over fiber, it gets very lost on people very quickly, which is totally okay. It gets a little lost on me sometimes.
Can you bypass the active receiver component if you want to use it in the other direction?
You cannot bypass for using it as a transmit. One thing that is cool with these, if there's no voltage being sent, it will work as a passive receive antenna, but it does not work as a transmit antenna. Or I should say, technically it will work once. Italy does not find that joke as funny. They say, Jeff, but it does not work once, and we have protection and all this and this. And it's a joke, guys. It's a joke. They're very, very smart people over there. Some of the jokes don't quite translate. To answer your next question, I speak zero Italian. Tom might speak some. I just know the most. Nessun problema, no problem.
Very well. I understood everything you're saying.
So as far as, of those antennas, do I use an omni, do I use a directional? It comes down to application. We spoke about this for anyone who's in our earlier session, it comes down to kind of what is it you need to do. The omnis being 360 degree versus the directionals being 120. And what is my coverage area? What do I need to cover? What am I expected to cover? You know, so as we discussed for those just joining us, if I was covering this room, I'd probably use a couple of omnis. If I was down on the street and I know everyone's going one way, I would do directionals. Tends to be kind of the thing. So Tom, what a great question. All of these are just building blocks? Great question, Tom. You're just really on it. I should have given you the things. So as we talk about, so you asked, someone's asking about when we start getting multi-zone, right? How do we, you know, like the MET, that sounds cool, but what we're really doing, you know, we talk about RF101 being signal to noise. We're chasing the same thing here, but all we're really doing is summing multiple zones of antennas and summing all of our antennas. So we have a transmitter, and on the right side, and if you ever get into a project that I'm drawing in CAD, because all of this is all CAD files to me in my mind, all of our signal flow is going to the left. So where we go into this is we say, well, I'm in a situation where I'm being asked to build a larger show. What do I need to do? What are the building blocks I need to do here? Well, right now we start with a receiver. This could be 4 receivers. It could be whatever, distro. That part doesn't matter to me. It doesn't matter to me what receiver it is specifically. It should be a Wizy. It could be whatever. But we have an A antenna and a B antenna. That's what I care about here. So then, what about when we need to expand? I then add an MAT. And all I'm really doing is adding that A and B back, and then a second A and B, and then even an A and B over fiber. And all of that is summing all the A's down to one output, summing all the B's down to one output to put that into our receivers. And in some cases we may sum it down and split it again. But the whole point generally being that it's a shared resource. Because a lot of people will approach this and say, you know, let's say for example we talk about Love is Blind, or we have to do a shoot where, you know, we run from here down into the subway station. There's a lot of people who will approach that and say, okay, well, the way I know how to do this is I'll just put another receiver down there. Let's say I'll drop a bag, and I'll have a receiver up here, and they'll just run from one receiver down to the next. And that works. That's fine. But there's another way you can do this. There's a way more sophisticated way that you can do this and have it all come back to one. We do this a lot for, you know, churches' broadcast environments where, you know, maybe it's not in the budget to have an extra set of receivers. It's not in the functionality that now you've got to get audio back from all of those, because maybe you're live and you can't have drop bags and multi-source of audio, because then your audio person's having to switch. And I've met a lot of audio people. Some are very, very talented. Some are audio people that are just there. I'm sure you've run the same. So this lets you take and say, well, now my mic can walk across all these zones. My mic's coverage area went from, let's say, you know, 200 feet around my antenna to now 200 feet of this zone, 200 feet of this zone, 200 feet of that zone. And depending on the mic itself, maybe it's 2, maybe it's 5, depending on the brand and a lot of settings and signal noise, all that jazz. You know, so is that kind of making sense? I know this is a little on the looser side of explanation and theory, little theory. Question from Tom. Fiber seems overwhelming. Is it better? What a great question, Tom. So we talk about copper, and this is RF cable. You'll see, you know, we've got little ones here, and I'm sure after this, Nate can take you back and show you the big 100-foot, you know, LMR 400 spools. If you've never dealt with one, I can see by the head shakes you have. You deal with 100-foot thing of LMR 400 that you have to wrap, and immediately you're going to say, yeah, I never want to do that again. Because in RF world and cable generally speaking, you want low loss. Low loss tends to have to be thicker cable, and thicker cable is heavier, it's more expensive. So just to talk about like the fiber and the size and scale of what we're talking about. So this interconductor, so think of like if you ever had coaxial television growing up that you had to turn your Nintendo to channel 3 and it was plugged in via the white cable coming out the wall. Coaxial cable, all basically the same, copper core or metal core, and then shielding, rubber, all that jazz. The interconductor diameter, does anyone know how large that is on an LMR 400 cable? This is in millimeters, by the way. Half a millimeter? 3? So close, 2.74 millimeter for LMR 400. So then we get to talking about fiber, and Tom can Vanna White this. Sorry, it's chunked up a little bit. My cats found it and they started nibbling on it, because you can't leave anything in my house anywhere. Same with whip antennas. Just show it off in a second. So we talk about what is the inner core, because fiber at its core is glass. So it's fine that no one will get this. Is in micrometers. The inner core diameter of this is inside of the blue part, 9 micrometers. And in case, and you can pass that around as well, Tom. In case you don't know your metric conversions, that's 0.009 millimeters. Like, we're talking a tiny, tiny thing of light. So, to one of the questions that I struggled not to put this slide in like 40 times of why does this matter? It's a great question. So let's talk about loss. Because everything, again, we're always going to come back to the same thing of signal to noise. When you run long cables, or run any cables, you're going to have inherent loss. So in like the good cable, like LMR 400 or 9913, or any of the good low loss cables, and Gotham will have a whole selection, there's a few to choose from, the average loss is about 3 dB per 100 feet. As you know, 3 dB is double or half. Depending on the cable you're using, that loss is remarkably higher. So if you use like an RG8X and you go 100 feet, I think it's something like 12 or 15 dB of loss. It's crazy, the amount of loss on it. Knowing that, anyone want to take a guess on what the loss on fiber is? There is a loss.
Say -2.
Close. So you in fiber you lose about 0.3 dB per kilometer. So we're talking 3 dB per 100 feet on a cable that weighs 100 pounds or something, versus that little strand, you're losing 0.3 per kilometer. To which I don't know the conversion of kilometer to feet. It's a long way. So is that kind of tracking? This is why we get into fiber, is your flexibility to deal with long ranges becomes easier. And even we don't even get long range, we start talking even 100 feet, because to have a strand, and you know, we've done this project with a few of the customers, is to have a strand to go from 100 feet to 1,000 feet is the same, because you just get a 1,000-foot strand or 500-foot strand, put it on your cart, and now whether your remote zone is 100, 200, 300, you just keep pulling, and the loss remains the same.
Could you put a buffer as like a junction box for that sort of thing, for that sort of signal?
What do you mean?
Like boost the signal every kilometer? Or?
So 0.3 dB is a pretty negligible amount in the grand scheme. And here's why you don't even really need to do that. Is the BFLs will put out 4 milliwatt of laser, which does not seem like a lot. But in the world of laser, 6 dBm, that's a very powerful amount of light. Assuming you're losing 3 dB per kilometer, 3 or 4. You're losing basically nothing. You'll lose a little bit in junction boxes here and there, but as long as you're hitting the BFLR at about a half a milliwatt, you'll be fine. So there's a whole thing I didn't put in here about link budgets and how much you're losing. You start with 4 milliwatts, get down to a half a milliwatt, you've got a huge amount of potential you could do. So you don't particularly need to reamp it partway down, because your loss is so incredibly minimal. So does that track? I know we're really, if we're talking about the excitement curve, this is how I explain it to the sales guys when we do these trainings. Everyone's like, oh no, this is I'm like, the excitement's only ramping up from here, guys. We got graphs and math coming up next. So any questions? Otherwise I know Tom's next question. Does any fiber work the same way? That's a good question, Tom. There are many types of fiber, and this is where these are the things that are massively important, that will, if you get it wrong, it will trip you up and cause a huge amount of problems. The first being, there are a few types of fiber optics that are common, but the two most common are single mode versus multi-mode fiber. And this has to do with how that inner core being 9 micrometers versus like I think it's something like 90 or 50 or 90 or 100 or something, and how the light is managed and how the laser is dealt with. It's all a very, very technical thing. For the takeaway from the slide is anything for Wisycom RF over fiber is going to be single mode. It is not negotiable. It is none of that. It has to be single mode. There are a lot of multi-mode uses out there, like in network applications, or if you've spent any time in like live environments, like the Digico opticore loop. All of that is multi-mode. Everything for RF over fiber is single mode. So now, thank you, Tom. Which is the right connector? And again, prefacing, I did not give these questions to Tom. That's my fault. It's a great question, Tom. Which is the right connector? To get to that, we start talking about, this is a small selection of the amount of connectors out there for fiber. Fiber is, in a lot of ways, to my opinion, a mess with the amount of connectors. It's silly. Let's go like audio. There's an XLR, there's a 1/4 inch. Let's not get complicated. But the ones that really matter are, the ones you'll see the most commonly are LC, ST, SC, and FC. Some of this will not probably ever matter to you, but all of it being, all of the BFLs and all the Wisycom stuff is SC APC. And your next question, well, we talked about SC or LC being the shape of the external connector. What is the next 3 letters? Also a great question, Tom. The next letter is being about the connector itself. So if you have that green cable that's going around still, if you don't mind, Tom, on the green side of the connector, you'll see, if you noticed, and you can pass this again, you'll see this cone shape. And that has to do with the type. So there's 3 common types of connectors. And understanding this will prevent you a world of issues. There's PC, UPC, and APC. PC being a very, very flat, UPC being a little less flat, APC having that cone shape. And the value of it being that the angle of that cone reduces the amount of reflection. Because in all of this, we want to, again, we're always playing this game of signal to noise. And we don't want to create more noise in our system. So we want to reduce the amount of, because it's light. Light works like any other, the lasers work like any other light. It gets reflections. So when you talk about going through a jumper, or like, from your BFL to a patch bay to your cable, to your next patch bay, to the cable, to the next BFL, you get all these connectors. And what we want to do is mitigate how much of that light reflects back into itself. So the APC will bounce it off and keep your noise down. Is that kind of tracking? I know we went just way up on the fun curve of exponential.
Is the takeaway here that the APC then is the desired connection?
Yes, APC is going to be your, SC APC is the connector, and APC across your whole signal chain is going to be the most important. There are situations where you'll have to use UPC because some fiber systems are built on UPC, like the long tack fibers, like multi-strand, they'll call them tactical, are UPC. And the big thing is making sure that if you have a UPC, you don't try to do an APC connector to a UPC. It'll be like trying to do a XLR to a 1/4 inch. It just doesn't really work. You're gonna lose a bunch of signal. But if you do XLR to XLR, and in the cable go XLR to 1/4, then you can plug into a 1/4 jumper. That tracks a little better.
Practically speaking, how would you put a safety in a run like this? It looks like such delicate cabling.
So for safety in a run like that, this is one that I bought on Amazon because it has this little like metal shielding. Generally, I wouldn't use any cable like this one for more than a couple feet. They make, and I don't know if they have some here, Nate, some of the good tactical, like very well insulated, well shielded metal versions that are meant to do 500,000 foot. 'Cause larger applications will run 10, 20,000 foot spans. Like I know the guys who do the guys and girls who do like networking for like Coachella. They put tens, 20,000s of feet of fiber buried in the ground. So it doesn't matter to do a 10,000 foot run. It's just like an armored version, if you will.
Use it. The other part of that I should have said was like a tension, like maybe by the connector, would you put some kind of tension loop on it or?
Yes. So for the connectors itself, one of the most important things in fiber is inside of this is a strand of glass. It's a very flexible glass, but you always want to be mindful of your minimum bend radius per the cable. So when you get to like your, let's say you have a cart, you have a fiber, and you have a 1,000-foot spool, to make sure you have a safety thing so it's not going to rip your connectors out and pull the cable, because it is frail. It's glass inside. Is that kind of what you're asking? Which is why on all of the, I think some of the things I've seen Nick come up with here is like Opticon quads and duos for doing long runs to a Pelican or whatever, and to do a jumper from your BFL to a spool, so you're not going spool directly in. So all of that to say, fiber is very, very attainable. It's just understanding some of the like simple things. So we run into things where people will use, we look at like the SCAPC and SCUPC look incredibly similar. So when you plug a UPC jumper in, we had this just a few weeks ago with a customer from Texas that he was saying he's running his scans and his noise floors are 40 dB higher than without the fiber. And I would say, well, that's not the fault of this. Let's find out why. Turns out there was a UPC cable in there going straight. And when it introduces a bunch of extra light, it brings the noise floor up because it doesn't know how to contend with that. So in the same way we're doing with RF signal noise, it's the same fiber signal noise. No,
So
sure.
just the difference between this UPC and APC is just the connector seems the same. It's just the colors. Right?
Yeah, so typically on a UPC it's going to be a blue connector, and then APC is going to be green. This is usually the case, but sometimes the we'll call it low-cost, high-quantity manufacturers in other parts of the world just get creative with the colors they're using, and it's less helpful. But you can tell when you see it, and I'm sure they've got all kinds of jumpers you can see here. You'll be able to look and see that on an APC it looks like a cone. So one of the most important things in fiber is filters. In the same way we talk about filters on the antennas, it's even more important to deal with that on the fiber. Excuse me. So on the BFL and the MFL, which we'll talk about in a second, we've done this for you. All of the filtering is built in. So in the same way we talk about the LFA, there being a tunable filter, selectable high pass, low pass, and then a fixed filter, all of that is built into the BFL. So this is kind of an internal diagram of what's going on there, but when you power it on and you put the voltage in, it'll select your low pass, your high pass, or your filter settings, and it's all managed internally. Because fiber, one of the key takeaways is your distances are basically unlimited, but your power levels are very, very capped. 0 dBm kind of being your max. If you overload the fiber, the first thing you'll see is intermod and noise skyrocket on the remote side. There's really not a tolerance for overloading. So we have some limiters, we have some things built into the BFL to deal with that, attenuators. But the whole goal being, don't overload your fiber. So for this, there's really two options that we kind of make, and there are some options from other manufacturers, but one of the things that we did early on with this is it's a purpose-built laser to deal with RF over fiber, because wireless mics, as I'm sure you've seen if you run anything, are massively dynamic in the levels that you're getting. A lot of the systems out there are built using lasers for satellite communication, which has a very, very small dynamic range. So a lot of them will publish that they have about 60 dB of usable dynamic range. The BFLT gives you about 90, whereas a coax cable you end up with about 120. And everything being signal noise, you get more signal to noise on this. So you can use this IFB antenna, and it's a single channel throwdown. And you'll see, Tom, if you want to Vanna White this one. So BFL, TBFR, you can mount a couple on your cart. If you're ambitious, I've been waiting to see someone mount them into a bag and just carry around like a, I don't know if you've ever seen the camera dudes with the SMPTE cables clipped to their belt. I'd be massively curious to see someone clip a SMPTE cable or a fiber cable to their belt and fiber into their bag. That'd be cool to me. I'm overthinking probably, but that's how I'd think about doing it. Probably massively impractical, but it'd be fun to talk about.
Somewhere and then.
Yeah, exactly. And like, how heavy really is the MRK? Can I put it around me? Like, or could I just put it all there and like a Scorpio with the Dante? I mean, how free moving do I really? Never mind. But this is why I would probably do very badly in this world. Way over engineer things. But it's powered off that the Hiroshi, or you can power it for the receive. You can power it off voltage from your receiver. It's got Bluetooth, so you can use the Wisycom app to remote control it. So when you drop a zone or drop an antenna zone out wherever, you don't have to climb up the pole to fix it. You can just walk up to it, open the app, change filter, change gain settings from your phone. And then of the other form factor is, this is probably something, it's a little more of the complex, but it's basically four BFLs built into a 1RU chassis. So if you're doing a multi-zone, you say, well, I need diversity coverage coming back, and I need to send IFBs out. So you can do all that in one box, or you can use BFLs to do antenna, and then separately IFB. So any questions on anything, any of that? Everything kind of tracking?
You talked about like going into a subway and all that stuff. Were you like saying you would like run cable down to the subway?
Yeah, so if we're talking about going to the subway, yeah. We just run cable to wherever that coverage zone is expected to be. And this is where it's a shift in like how the paradigm of how you might be doing your work and how you could be doing your work is different. Sorry that I can't hear the beeping. So it's a little bit of a shift. Instead of saying, well, I'll shoot this scene here, and then as soon as it's done, I'm going to run over to that one and be ready to do that. Because I know there are days in productions where they're doing back to back to back to back, and you're constantly running and doing whatever it is. What we're saying is, well, instead of that, let's bring antenna coverage from each of these places, plus, Video Village, plus where they're getting prepped. Let's bring it all back and just make it all work from one location. This could be, to Tom's next questions, are there limits to this? And the answer really ends up being kind of no. You can take all of these building blocks, and that becomes the whole point of this, is these are all just building blocks that you can take and expand to fit whatever it is you need to do or you want to do. So like a couple examples of this is these are all Wisycom Italy slides, so they're all European theaters. So like, let's take an example of a theater. And the same thing applies whether you're doing install or portable, whatever it may be. The building blocks remain the same. A local zone via copper at front of house and then a fiber zone to the back. Or you want to expand a little bit more and we're putting fiber zones all throughout the front of house, copper zones all throughout the back. Or maybe you want to get more complicated and you want to have theaters in separate buildings or separate spaces. You can combine them all via fiber and MATs to distribute it to your receivers. Or this one, which I forgot that we had the stuff for. We did this Q&A with Nick earlier online, and I was talking about coordinating 30-40 channels of wireless, and he said, "Oh, that sounds like a nightmare." This was done by our British partner for a Netflix series. I'll let you guess which one. And if anyone wants to guess on how many channels of wireless that is. Yeah. 256 channels of wireless.
This is busy for.
Yeah, those are all of these MCRs and MRKs on this side. So that's 64 channels there, 64 there, and these are our 2-channel rack receivers. So that's 32, 32, 32, 32. And then basically it was just big zones inside of a hangar for our 256 channels of wireless. So the end up being, you can do basically anything with this, just understanding the building blocks and understanding some of the rules of, cable lengths, where do we transition from coax to fibers? If I have to set it up, I'm not going more than 100 feet. Someone else is pulling, let's say 400 is our copper max. But that's where we're going to say, well, after 400, let's start talking fiber.
Yeah. The squid game scenario makes sense to me. Huge scale, it makes sense. I don't understand the theater scenario. Why do I need receivers in the audience?
So this is one of those things of, what is the application? And in this application, we, the pitch on this ends up being, let's make the microphones a shared resource. In a theater like this, the request ends up being, well, we want the mics to work on the stage, but also we sometimes have events where we want them to work, we want to do things in the front foyer. So instead of having to lug mic receivers out every time we have to do it, let's just make the mic walk everywhere. Or if we do a small performance out there, we can bring the mics out. Because once you have the RF from the transmission into the receiver, to move audio is easy. Be it Dante or Maddie or even analog, whatever it is, it's easy to move audio. RF is a little more challenging. So, they use all of this in this example as a shared resource that my mic can now walk everywhere. Because there's a lot of applications for, location sound, reality, film, television, broadcast, whatever it may be. But on the install side, the approach is a little different. So is that kind of...
Yeah, the use case.
Yeah, it's the use cases. And this ultimately comes back to what, when we started at the beginning of, well, what do we need to do? What do I need to cover? So like when I get asked this and I'm designing, whether it's an install or a show, my questions of being like, how many channels is it and where do you need it to work? What do we need to do with this? So if I need it to work in a building over here and a building down there, then I'm going to focus more on fiber and making sure I can get them both. Like if I need to walk from this building to this building, I'm going to approach it differently. Or if I don't need 2 buildings, but I need to do 256 channels, I'm going to approach that in a different way. It's just understanding the building blocks you have available to fit the applications you're being asked from your production.
How do you power the transmitter and receiver for the fiber?
So the BFL powers via the 4-pin Hiroshi. So you have a little, I thought I got one out. Maybe I did or didn't. Oh, I did. Yeah, so it's just 4-pin Hiroshi. And you can power that via the plug, or we've done some where if it's a portable application. There was a guy who sent me a really cool thing the other day. They built it into a Pelican with a battery mounted on the top. 2 BFLs with power and Opticon on the side and a big V-mount battery off the top. Said it's not really waterproof anymore, but it's cool. You could do basically anything. It's just what is it you need to do and what is it you're being asked to do.
So we need a rack.
So the BFL, you can do BFL to BFL. So you can do fiber without any additional rack pieces, because all you need is, you'll see on here they look the same. This one's got it's optical receiver, it's called a photodiode, and this one has a laser output. So all you really need is transmit, receive, and then it's converting coaxial in, fiber out, and then fiber in, coaxial out. So you could do that on its own. It's when you want to start getting multiple sets is when you need an MAT.
Well, where's the audio output for that? I guess I'm also thinking bags scenario or even cart. That doesn't require a rack.
So for the bag situation, it's not the BFL, because there's no audio in this necessarily. All we're doing is extending your antenna cable out.
Oh, I see. So the BNC connection from that goes into
your mic receiver. Yeah. Yeah. So you're transmitting RF, and then audio is the final stage. All you're doing is basically replacing a coaxial cable with BFLs and a fiber cable. There it is. That's what I always tell people. I told Tom and all the sales guys as we got into this, I was like, there's going to be a point where everything kind of makes sense, because some of this is, it's complex in that there's not similar equivalents out there to it. There's not really another MAT, so there's not really another fiber solution. So it's shifting how you think about what's available. There's someone else who was asking something.
I had a question about how many antenna or fiber connections you have outside that big rack mount there. Is it just one?
So the MAT itself is just coaxial inputs. It's all copper. So what you would do is remote antenna, coaxial in, fiber to BFL receive, coaxial to MAT, MAT to mic receiver. So think signal flow going this way. We're just replacing a long run of coax with fiber. So your limitation ends up being how many zones you can put in this, which ends up being 4 diversity zones. Now, if we're talking with the MRK, we have this expansion card. What that allows you to do is instead of going BFLT to BFLR, you can go BFLT to MRK and then cascade into your inputs. So there's just a few different tools, the tools to do those things.